Welcome everyone. Today I'm going to show you how to record a theta scan and a rocking curve on our omega theta. Now I've gone ahead and placed a silicon wafer in the system, and I've done the height alignment and already placed the tube in the theta position, so it's now moved back. When I run a theta scan, I should need to select a theta scan recipe. Change the name and start it. So what is a theta scan? Basically, it is the measurement of crystal orientation that we can also do on a conventional multipurpose diffractometer. We've gone ahead and calculated where we should see a Bragg peak for our sample, using the main orientation in the material, and now we are scanning around that area and recording where we actually find it. Might be, I don't know, 1/10 of a degree, half a degree away. Then we rotate the sample 90 degrees, as has just happened, and record again until we have 4 patterns like this. I've now set it up to afterwards also automatically record a rocking curve once we have the tilt and tilt direction. So now it will turn the wafer accordingly. Do the scan one time fast, just to make sure we actually have the peak in our scan range, and then repeat the scan slower. Both of these scans are recorded with a monochromator inside. Without the monochromator, the optics on this system will only allow us to say something about where the peak is, but we cannot say anything about the width of the peak. And that was the critical parameter you usually want from a rocking curve, but I'll explain a bit more on that later. Now, here we see our rocking curve coming in. The scanned area is much narrower and the peak is very, very narrow. And there we go. So now we've measured our theta scan, and from a theta scan we will get the tilt and the tilt direction, plus the comp 0 and comp 90. We do not get a stereographic projection, and we do not get all the other directions within the crystal, or things like the reference offset, because we just have not measured enough information to find those angles. Now, we also get, because we did a rocking curve afterwards, get our full width half maximum here, which is 0.003 of a degree. Now, if I have a closer look at the scan for the rocking curve, we can see that it is quite narrow, even if we have a little zigzag here on top of the peak. We're only looking at the area between -0.2 and -0.16 degree. The scans we used for the theta scan are much wider. Yeah, I'm showing them now down here. You see that this is from 0.38 to 0.37, and they are, these peaks are just much wider. They are good enough to find where the peak is, but not good enough to show anything about the crystal quality. Now, if you want to set up a theta scan with a rocking curve, this is what the recipe will look like. Now we have the name which we select from, which is based on the peak we're measuring and the material. And we need to provide a theta/Bragg angle, which we do via the diffraction calculator. In a diffraction calculator, you have the crystal structure known, you provide the main axis and press calculate, and then it shows you here which reflections are allowed for this material and orientation. So for silicon, we have the option, silicon 001, we have the options of 002, 004, 006. Now, this is up to the operator to, 1, provide the right structure information, and 2, to select which peak they want to measure. And we need to know, in this case as operator, that for silicon you want to measure the 004 peak because it's the most intense and it's an easy scanning range. So we select that, and we get the value here. We know that the sample should not have a large tilt angle, so the tilt search will also not activate until we have a larger tilt angle. We're just using the flat stop, nothing fancy, and I like to use the symmetrical tilts, even though it says only for high tilt, but that's I like to use it in any case. Down here I've activated the rocking curve measurement to measure around this angle with a range of 3 degrees, so we will definitely find the peak, and then a scan resolution of 5/10,000ths of a degree and a speed of 0.1 degree per second. We can set some parameters for the peak surge, and also quite importantly, we set a different we set 30 kilovolts and 30 milliamps for our tube when we're measuring a rocking curve, because then we're using our monochromator, and the monochromator of course filters out a lot of radiation. So that was just a quick introduction to how you can measure theta scans and rocking curves with your omega theta. Thank you for watching.